Saturday afternoon. Saturday, Friday afternoon. Saturday afternoon. Monday, Friday Harish will come on. Friday Harish having Saturday Harish having. Saturday morning you will go. You can adjust the class. I will ask Harish to do on Friday. Just sign it here. We will intercept that. Pen sir.
This one.
Yes, sir. So Saturday morning you can go, no? Saturday. I will ask Harish to go by Friday afternoon. Friday afternoon. Okay.
This one, please submit it as well. Those are completed.
Good morning, all the dignitaries, faculty members, and PG students. Welcome you all to the third day of ATAL activity. Today's chief guest is Venkatramana. Now I am going to introduce our chief guest. Venkatramana worked as an assistant professor at Shri Engineering College, Tirupati, and Srinivasa Institute of Technology and Management Studies, and guided students in project realization. Worked as research fellow at Defense Bioengineering and Electromechanical Laboratory. Contributed for the project design and development of integrated life support system for light combat aircraft on electronic control unit and health monitoring system. Worked as DET at Electronics Corporation of India Limited, Department of Atomic Energy. Contributed for the project fast breeder nuclear reactor prototype on development of instrumentation and control system. Currently serving as a scientist at Combat Vehicles and Research and Development Establishment, DRDO, Ministry of Defense, working in and Battle Tank Arjun Design and Development Programs. Core Strength Gun Control System, Design and Development Electro-Hydraulic Based, Design and Development of Electric Gun and Turret Drive System for Armored Fighting Vehicles, ATE Development for GCS Electronics to cater for easier diagnosis and fault diagnosis. Integrated Troop Level Main Battle Tank Training Simulator based on 6 DOF motion platform. Function, roles and key areas are AFP development for Indian Armed Forces. Institutional memberships are member of Instrument Society of India, member of ISTE, member of IETE, and published research papers at ISOI journals and national conferences. Thank you. Now, I request Dr. Lakshmikant Reddy, Principal of MTIEAT, to give address for our ATAL activity. All the dignitaries too. Invite as.
Good morning, all of you. Good morning, sir. On behalf of management, faculty, and on behalf of you, also I invite today's chief guest, Dr. N. Venkatramana, scientist at DRDO, Chennai. We welcome you, sir. We thank you for accepting our invitation for this today's speaker. Thank you, sir. And also, last 2 days you already enjoyed with the excellent sessions. Today also it will be worthful and entertained sessions will be there. I hope you will enjoy the sessions. With these few comments, I request Dr. Sarana sir to speak few words on this occasion.
Thank you, sir. So again, I heartily welcome today's chief guest, Dr. Venkatramana, scientist from DRDO, and our principal, Dr. Lakshmikant Reddy, sir, and all the department faculties, and all the participants. So this is the third day actually. So I hope you enjoyed last 2 days. Definitely this day also will be very fruitful session, no doubt in that. So in this occasion, I want to share one information through one story. Can I? Yes. Thank you. Actually, many times this story I given to my students actually. This is the first time. This is the right time and the right place to tell this story actually. Actually, in Japan, one guy actually invented one piston. Okay. After made the piston, he want to get recognition. No, he want to for getting recognition. Actually, it's happened in 1947, during the period of 1947. For getting recognition, at that time in Japan, Toyota company is the famous company. So for getting recognition, he went to the company. He showed piston design, everything is shown. But those people, they are not recognition actually. They didn't recognize. Instead of recognize, they discourage and send him out actually. After coming out, he didn't lose his confidence. Again, whatever he is having asset, no, he sold all the assets. He started one company. Almost a company started. What he expected, no, actually he want to manufacture the piston. That also he manufactured. So everything ready. Now the piston is going to ready to sell in the market. That is the condition actually. But unfortunately, at the time, earthquake happened. So total company collapsed. But that guy, he didn't lose his confidence. He didn't lose his hope actually. Again, he started the same company. Compared to previous time, like a big company, and the manufacturing, a number of manufacturing also more. Again, the piston ready to sell it to the market. That is the condition. But the guy again is getting unlikely. You know, already in 1947 during that period, Hiroshima and Nagasaki. Okay, the bomb blast happened. No, due to that, again the company collapsed. But that guy, he never lose his confidence. Even he never lose his hope actually. Again he started. Finally he succeeded. We know that is one of the famous company in the world now. That is Honda company. Why I am saying actually we have the final year PG students and PG MBA students. After completing the degree, we are not seeking only the job. We never think about the entrepreneur. So nowadays many options are provided by the government. Okay, just if you have idea, that is sufficient. You can become an entrepreneur. No need to spend money also. So that much option they are provided from the government. So I hope you all know about pattern. Okay. So through the pattern, if you have idea, I think you don't know like Swiggy. What they did actually, like through one app actually, they didn't spend any money, only idea. Through that idea, you can come as an entrepreneur. You think like that. Okay, so only always everyone after complete the degree only we need a job. We need to work in some company. If you are working some company now, your family only will benefit. Correct? Suppose if you become an entrepreneur, you can make many families to be happy. Okay, so think like that. With these comments, I'll request Dr. Venkatramana to give few words about today's session.
Good morning all. Shri, thankful to Mr. Sir and Sir for having invited me here in this session. It's an honor to explain the concepts to these students. It's an honor to be here. Thank you, sir, once again for inviting me here. Thank you, madam, for the introduction. Without spending much time, we start the presentation. I like after listening to Principal Sir and Sir, what I just understood. So this program I think went out. So it is like FDP, Faculty Development Program. So like a very important program. And before that, I really want to appreciate all the faculty members attending this course. So there is no end for learning, and there is no end for putting our efforts. As Sir told my story, there is no end for hard work or learning, whatever I would say. So everyone, each one of us should keep learning, keep updating ourselves. So I also came to some of the students also there from PG, post-graduation students. It's a really appreciative. And it's a very noticeable thing is students from MBA background. MBA students also there here. It's very good actually. I surprised initially, but good. So there are a lot of commercial things also there. Whenever we talk about solar power, space-based solar power, obviously there are a lot of scope for commercial things to be happening. So like this is the third day. So I'll try to cover whatever as per schedule. And there will be some 1 or 2 points or like maybe repetitions. Please bear with me. Since it is third day, maybe some basics, some history and background. So see, these things will be maybe repeated. May get more. Please bear with me. And we will try to concentrate more on design part. So how we can develop, how we can design photovoltaic cell, how we can design subsystems required for space-based solar systems. The point here, like a lot of work to be done. There is a lot of scope for space-based solar power. A lot of things to be happening in the future. So this note, once again my thanks to Professor and Sir. So we will start. Thank you once again.
Before starting, a small illustration to Venkatramana sir.
Good morning. Good morning, sir. Am I audible?
Yes, sir.
Then I don't need mic. Myself is a mic. Before starting our session, let's see the importance of power basically. Then why we are going for solar power? Then why space-based solar power is required today? May I know who are the faculties? Just raise your hand. Okay, good. No, learning is always, always required. PG students. PG electronics. MBA, I know. PG which stream? Power systems. Oh my God, great. Okay, any apart from power systems? Okay, good, very good. And MBA? Oh my God. MBA? MBA which stream? Finance? HR? Marketing. Great. Who knows marketing? Great, really great. HR? Finance? Acha, is it combined this one, not individual? I'll combine this one. Okay, good. Acha, based on your interest, you can choose. Okay, you can maybe finance and business also. Okay, good, nice. How many are from technical background, like electrical engineering or electronics engineering? BTech, or BE or BSc? No one. Okay, fine. No, basically I have to curate myself. Okay, good, no issue. Okay, then I try to cover more of commercial terms, more of like entrepreneurship kind of details, and more of business oriented. Will it be okay?
Yes, sir.
Okay, fine. Good. Okay. PC electrical. Anyone? Anyway, okay, you try to understand. In between some technical things will come now and then. Please bear with me. Try to understand. So generally, which we are seeing first time, which we don't know anything about that. We'll have some enthusiasm to know what is that. We'll have some interest to know what is that. Okay, fine. So you see that idea. Okay. So for example, I'm basically from BTech ECE, and I'm tech from instrumentation and control systems from IT Madras, and I'm like looking for PhD tech 5 years. Okay. This is my technical background. And coming to MBA side, I'm zero. Literally, I have to admit. Okay. Okay. So in that aspects, I'll just try to short our session. Yeah. Like why this power is required basically. See, if you see your home, if you see your college, if you see outside any place like airport, like railway station or bus stand, wherever you go, without power, will all these will run? No. Power is required. Correct, na? Now, power means again, what are the different ways of generating power, using the power, transporting the power. Okay, so there are lot many ways. Okay, now conventional electricity, one thing, and secondly wind power, hydro energy, then solar power. Yeah, many are there. Now, even though all these different, fields of power is there, but still why? We are unable to meet the required demand. We are unable to meet the requirements as of today. Okay, can we think of in India 24/7, 365 days power available? Is it possible? No, is it not possible? Okay, I'll say like this: 365/2. Is it possible? Maybe yes, but still we can have lot of rural India where this power availability is a problem. The problem is they get only hardly 3-4 hours current in the rural India. If you see the major part of India is a rural only. Agree? See, only few part of India is metropolitan cities, towns, all this, right? We agree with me. Most of the India is rural part of India only, right? So why still this requirement of power is there in a sense? Now I'm coming to the point. Even though you generate the power from different ways, still we are unable to meet the requirements, power requirements. Today we are having scarcity. We are going to face scarcity in terms of fuels, fossil fuels, in terms of coal, in terms of gases. And after 2 or 3 decades, even earlier than this, all sources may be complete. All sources may be over, may be completed, may be fulfilled. There may not be availability of these sources for the coming generations, future generations. Now we have to think of what is the alternatives. What are the alternatives? This is the time to think of alternatives. If you are not working on alternatives today, when we will work on alternatives? Very difficult. We cannot face the future challenges. We cannot face the future requirements. So here lies utilizing the solar energy, utilizing the energy coming from the natural source like the sun. Like one of the greatest source available for the universe is sun. Okay? Coming to this one, space-based solar power. It is always sunny in space. Agreed? It is always sunny on the earth. Agreed? Yes. Okay, how many are yes? Yeah, right. Okay, how many are no? That's what I'm asking. Okay, so my statement is it's always sunny on earth. Huh? No. Yes. Partial yes, partial no. Okay. Okay, partial yes, partial no. Okay, good. It's not so. On earth means 12 hours a day, 13 hours night. No. 12 hours night. Agreed? Okay, good. So I also know 12 hours a day, 12 hours a day. Night, 12 hours a day. Okay. 24 hours. Okay. Okay, fine. How you say 24 hours a day? Can we say 24, 26 hours a day? No? So your course will be complete before 2 months. I'll get salary more. Correct, no? So number of days will get reduced or will get increased. Or your course will become 2 months late. Huh? I will get very less salary. Instead of 12 months, 11 months only I will get. Correct? Okay. Anyway, fine. You know the history, no? How the 24 hours is decided, depending upon the revolutions. And how AM, how PM. What is AM? Now it is 10 AM or 11 AM. What is that AM? After 12 o'clock it will be 1 PM. Then what is that PM? Okay, fine. Since like mixture of students and faculties are there, I happen to go some different area out of our syllabus. Okay, good, nice. Point is on earth it is not always sunny days, right? So now winter season, rainy season, summer season, cold season, all will be there. Okay. So in summer season we will get the fullest of energy from sun. In the winter season, not fullest. In rainy season, very less, right? So that too 12 hours day. In that 12 hours a day, again we will get the maximum amount of energy from sun, maybe from 10 o'clock to evening 4 o'clock. Morning 10 o'clock to evening 4 o'clock. Sometimes 12 to 2. So very limited, very limited number of hours. We will get highest amount of energy from the sun. Okay, that's the point basically. So now, if you go to space, above the earth, space, there, what will be the condition? Is there any rainy season there? Is there any winter season there? Cold season there? No, only one season. Sunny season. ಅಂತ ಎಂಡಕಾಲ ಅಂತೆ ವರ್ಷಕಾಲ. ಓಕೆ, ಮಳೆಕಾಲ ಇಲ್ಲ. ಓಕೆ, ಎಲ್ಲಿ ತಮಿಳು? From Tamil Nadu, anybody from Tamil Nadu? Good, nice. Okay. Okay, good. So now we have to think the ways how to utilize the energy coming from sun. How to utilize the energy coming from sun? The sun rays, whatever coming from sun, how to utilize and how to capture it, how to convert that sun rays into electricity. How to use that electricity for our daily life purpose. How to utilize that energy, electric energy, for our future generations. How to make less dependency on our conventional ways of power generation, transportation, utilization, all these things. Okay, agreed? Now, even though you have multiple methods of varieties of availability of power generation from wind, from water, from coal, from fuel, still we are unable to meet the requirements of the power for the India. Okay, not only India, even other Western countries, European countries also. Okay, hence there is a requirement to go for space-based solar power. So that is the basis why this FDP is planned, I feel. Why you are all sitting here and why I am standing here. Okay, so we have to go out of this earth. We have to go out of this earth. Okay, physically we are here only. Okay, like I said. Okay, fine. Now, yeah, so everybody agreed the last statement is always sunny in space and always the sun rays are available, and it is possible to capture the sun rays from the sun. Okay, so this is the background. Before going present, this is the background. Okay. One more time, we have one more type of work on that. Yeah, right. This is the third day, right? So this is the third day for this program. Okay. How many of you know what are the countries already working on this space-based solar panels? Japan, China, USA. United States of America. What's the PRC? People's Republic of China. Okay. So nowadays you don't find any China name on the products. You will be finding only PRC. So if you see China name, don't purchase. If you see PRC, people don't know. Very few people know. So they will obviously purchase. So that is another way of marketing. Another way of doing business. Okay, fine. Normally from sun, huge amount of energy is coming out 24/7 into 365 days or 364 days, including leap year, whatever you say. Okay. Now, there are some techniques, there are some methodologies, there are some approaches people worked out, people are working on to capture this energy from sun rays, to capture this energy from sun rays and utilizing that sun rays for power, for generating the power. So in my childhood days, I mean you also sometimes you will see, there will be a lens. If you keep that lens on paper without moving, or 5 minutes or even less than that, at peak hour, at least 1 o'clock or 12 o'clock or 1:30 around so, if you keep 5 minutes that lens, what will happen? So the paper on that spot, just beneath the lens, it will get a hole or it will get a bone, it will get heated up. How? Again, it's the same principle here. So whatever solar rays coming from the sun, so that will be absorbed by the lens and that will be transmitted to the paper, and there the energy will be in the form of heat. So that heat energy will touch the paper and that particles in the paper will get heated up and that paper will get a hole or bone, whatever it is. So this is a basic principle. Okay, why don't we use this basic principle? So for a larger extent. Okay, yeah. So last 2 days you may be covering what's the background, history, all these things. So just I'll touch upon some very lightly on these areas. So what's the background? The global, the universe or the earth, and people needs energy. I mean the energy necessities are increasing day by day. Almost it is expected double or increase by 50% in coming 20 to 30 years. So as a result, it is essential to repeat to alternative methods of producing power. Solar, like the PV cell, photovoltaic cell, which utilizes the sun's clean energy. Yeah, here, what is clean energy? Yeah, what is clean energy? That means without interruption, without impurities, and without any mixer of type of this one. So clean energy that we get from the sun. Okay, so to meet the increasing demands, we are going for space-based solar power generation. Okay, yeah, but this solar PV cell, solar photovoltaic cell, so they are not always dependable, as I already told you. So only daytime we can work with PV cells, that too summer season, majorly, and very we don't use during rainy season, or if you use also very less only. Okay, yeah. So the dependency on these PV cells is not always. Yeah, hence we will go for space-based solar power, SBSP, which emerges as potential solution to the power problem, to the power concerns. Okay. This space-based solar power, it can provide 24/7, as I already indicated. There is no winter, no rainy season in the space. Always is a summer only. Sun energy always available. Also. Yeah. When it comes to achieving a net zero goal, the space-based solar power is becoming more viable option. You can depend on that. Can you say in space, sun may not be available for 2-3 days? I can't say, right? That means it is one prominent source. We can depend on it. We can depend. See, we don't know today power is there. After 1 hour, power may get cut because of rain. We don't know. Okay? But space-based solar power, we can depend. 24/7, 365 days we can depend. So that's the point here. So it's a viable solution. 100% viable solution. Space-based solar power. Okay? Right. Yeah. Is viable option. So the station, the solution, whatever presents a review of wireless power transmission. I'll come to that. What is the WPT? Wireless power transmission. I'll come to that. Okay. So just to introduce the state of information, the properties of the system, and modern space-based solar power models, along with the application and spillover effects with regard to different sectors, like that will be examined in our presentation. So what are the challenges, what are the risks involved in developing these systems, and what are the challenge in transportation of these systems from Earth to space. After developing the hardware in the laboratories, we have to transport this hardware to the space. That is also a challenge actually. So those things we will discuss. Okay. So the challenges and risks that which are involved, like we will discuss to address the key barriers for successful the solar power generation of space-based solar power taken as a task or project. So the technological obstacles, what are the difficulties? Technological, availability of the resources, availability of the required hardware, availability of the software for simulation, availability of the launch vehicles to transport the things from Earth to space. All these things we will discuss in the coming slides. Okay. So with the incremental advances in key areas and sustained investment, sustained investment. Yeah. So what is sustained investment? Coming to what is sustained investment? Yeah. What is the sustained investment in the sense? See this the hardware development of the space-based solar power. It's like one-time investment. So one time you develop the hardware. One time you develop the hardware. So that only one time only you will develop it. Then you will transport that hardware from Earth to space. What is that hardware? We will see. Okay. So this is one-time development cost, and you will get the power. I mean 24/7 into 365 days. Power you will get, but you are investing only one time. Okay. But what is the revenue? Revenue you are getting continuously. That means you are investing your money, your capital, one time to develop the hardware, which is required for a space-based solar power generation. But what is the revenue? What is the profit out of that? That you are enjoying after, after installation of that hardware in the space. From that point, you will be continuously, getting the revenue more than 10 years, 20 years until the lifetime of the hardware. Okay, right. What is the sustained investment? That means if you develop one hardware, will you stop it there? No. Okay. See, space is not 1 kilometer. Space is not 10 kilometer. Space is not 10,000 kilometer. Okay. It is more than this. Okay. So like that, you will be developing another sets of the same hardware after 2 years. After 2 years, another set. After 3 years, another set. That means sustained investment. Again, you will be transporting this hardware to space. Again, you will be getting power from each station, each set of hardware. That means you are investing continuously and you are getting the revenue also continuously. You understood? It is a process. It's a continuous process. It is a sustained investment in the sense. Don't stop it at one set of hardware. Don't stop it there. Then you improve the hardware and you improve the efficiency of the power generation, and you keep investing and then keep getting the revenue. So that's what I mean. Yeah, solar-based space power integrated with the other renewable could contribute significantly to cross-sector like decarbonization. Okay, what is decarbonization? What is carbonization basically? Like a lot of meetings are happening at Geneva. Lot of meetings are happening. Our goal is to get net zero carbon emissions. Our goal is to minimize the carbon emissions. Our goal is to increase the greenhouse energy. To increase the greenhouse energy. Okay. So that means carbon emission we have to reduce it. So if you use space-based solar power, then there is a good chances to reduce the carbon emissions, right? So you are using now e-vehicles, e-auto, e-bike, e-cycle, e-train, e-flight, just I'm telling you, okay? So there any carbon emissions is reduced, obviously it's reduced compared to your petrol, diesel, all these things, your carbon emissions are reduced. If you use this space-based power, still these carbon emissions will further go down. Okay, so that we will have the less amounts of emissions. Yeah. What are the trends of concern actually? if you see last maybe 50 years or 100 years or so, how this demand, how the history is there in the sense. So if you see the forecast of energy consumption, so if you see fossil fuels with the red color and non-fossil fuels with the gray color, if you see the amount of energy that consumed, like 2020, is the highest actually. 2023, 24, 25 is the highest. That means now the existing decade is the highest amount of power consumption, especially fossil fuels. So if you continue this fossil fuels, keep on using, at one point of time, definitely you don't get your petrol for your bike, you don't get your diesel for your car, you don't get your whatever diesel requirements for buses, trains, all that. You don't find any transportation furniture. If you want to go to some other place, you want to go by natural source like two legs. Okay. So now this is the point for concern. So how to reduce this? How to reduce this? Okay, so maybe if you work on a space-based solar power, coming 50 years or more than 30 years or more than that, 40, some estimation is there. So this, that amount of energy which is consumed, that may come down from 500, joules, 500 exajoules per year to some 300 or some 270 or 280 exajoules per year. So if you utilize other sources of energy apart from fossil fuels, your energy consumption will be reduced. Provided you have to keep on working. You have to keep working. You have to keep getting power from space, and you have to keep utilizing effectively whatever you get from space-based solar. Very important. It's very, now for discussion today, it looks very light, but it's a very serious concern actually. Okay, assume one situation, there is no fossil fuel at all. What we will do? Just assume today. Today you assume no petrol, bunks are available, no diesel. You want to go from one place to another place. You want to go to Tirupati, for example, from Chittoor or from Palamaneru. How will you go? By bus. No diesel for bus. That's what I'm telling. E-vehicles, electric vehicles. Okay, I discuss electric vehicles for 5 minutes. Since you told electric vehicles. How do you charge electric vehicle? Acha, now sir, here and there, Bharat petrol bunk is there, HP petrol bunk is there. So like that, we will have some charging stations, right? Okay. For example, for a petrol station, you will have the pump. You will have the pump to put some, 10 liters of petrol, 20 liters of petrol. Okay. Like that, what is there in charging station? Same pump. Same pump. We will insert. How? Okay, good. Anyway, good. No issue. It's kind of pump, but not petrol and diesel. It's like charging points will be there, and positive or negative two terminals will be there, and there will be a small connector kind of thing. Small connector kind of thing. Yeah. So that connector from the battery bank will be there in the charging station. There will be a battery bank. So that battery always under charging condition, fully charging condition. Okay. So from that battery, like your you will have the mobile ports different sizes, right? Like mini USB, micro USB, C type, B type, whatever is there. So like that, in the charging station also, you will have multiple types of connectors. Depending upon one connector will be charging station is same only. Battery bank is same only, but the output from that battery bank, you will get multiple connectors. One connector compatible for a e-bike, one connector compatible for e-car, one connector compatible for e-cycling, like that. Like your mobile, how you are getting different types of B type, C type, charging this one and all. So like that, charging station will have the different types of connectors. Okay. Now, in between your battery and one charge in the vehicle got over. Now what will do? Charging station is very far, maybe some 2 kilometers. Now what will do? Okay, one option, yeah, as you rightly pointed, sir, I will install one solar panel on my car. I will install one small PV cell, PV solar cell on my cycle, front side. Okay, yeah, one of the viable solution, right? Luckily, if it is sunny day, not rainy day, so I will get solar power from the PV cell, and at least for 1 kilometer, I'll try to manage. Another 1 kilometer, I will push the vehicle. Okay? Yeah. There are lot many ways are there. I am talking now. I can convert energy from my boards which are coming. I mean from my talking also I can generate energy. Like that, okay. And how much of energy? No, energy will be more from gents or girls. See, I am telling. I am talking. From this also I can convert energy. I can generate energy, power. From that, ladies and gents. I'll say this. You are not girls and boys, no? Okay, I'll say this. Ladies and gents. Now, from whom I get more energy? Mother is shouting more at home. Or wife is shouting more at home. Or my sister is shouting at me. Or fighting at me. That's true. Okay? So that vocal pitch for ladies and gents different. Okay? So that pitch is more for ladies and it will be not same for gents. Okay? So just for it's possible. Maybe today it's not possible, but it's possible. Okay? Okay, right. We are going somewhere else out of syllabus, right? Anyway, we are in energy only. We are discussing energy only. Even though out of syllabus, we are discussing other ways of getting energy only, right? Now you tell me statement. Is it a concern or not? Utilization of fossil fuels is increasing more and more. Is it a concern? Yes. All of you agree? So definitely there is a requirement to go for space-based solar power. Agree?
Yes, sir.
Yeah. So now we discuss that. I mean, energy growth trend. See, if you see the energy growth track, with the increase in the population from 1990 to 2010, 2020, 30, and how this economic growth is affecting. You see the graph. So the left-hand side, the vertical scale, billion kilowatt hours, and the horizontal scale number of kilos. I mean, 20, 30, all these things. There are 4 things noted here. Coal, red color, natural gas, yellow, nuclear energy, green, and renewable energy, blue, and oil and others, purple. Okay. The solar energy available in space is literally billions of times greater than the energy we use today. Okay. So if you combine all these 4-5 kinds of energies, oil, renewable, nuclear, natural, coal, whatever energy we are getting from all these sources, the space-based energy is more than this. Agreed? Agreed, right? Yeah. The lifetime of the sun is estimated 4-5 billion years. That estimation also, we don't maybe more than that also. Who can estimate perfectly? Can you estimate yourself perfectly? How many more years will you live? No, right? At least scientific can say. There are some techniques to predict actually. Now, obviously, it is more than 4-5 billion years. Okay? So, what is 1 billion? 10 lakhs. A billion, sorry. Billion. Okay? So, 10 billions. Okay? You see that using Google. Okay. Yeah, making space solar power truly long-term energy solution. Now you tell me, using this space-based solar energy, it is a permanent solution. It will give you the 100% requirements provided there are some pros and cons. Okay, what are those pros and cons? We will see. So at this time we are concluding that space-based, concluding means with this slide. So space-based solar power will give us 100% our fulfill. It will fulfill our 100% needs, 100% requirements for coming 20 years, 30 years, 100 years, more than that. Because sun's age estimated is 4-5 billion years. With this statement, I can say another more than 200, 300, I mean, this one number of days. Okay, obviously, yes, obviously sun energy is available. Agreed? Okay. Final step we'll see. What statement will conclude? Okay. So future energy options, like if you see this table, source, the first column, clean, I mean, how it is like the green energy or not, clean source or not, is it safe or not, reliable or not, and what is the base load? Okay. So different sources available, as you know, fossil fuel, nuclear source, wind power, ground solar, hydro, biofuels, and finally space solar power. If you see clean fossil fuel, is it a clean source? No. So we have to refine it. We have to subject that to a process, a procedure. Okay, you will get a crude oil basically from the earth. So that crude oil you are going to refine it. You are going to convert it to a clean petrol or diesel, whatever. So there is a process required. There is a process required. Secondly, nuclear source, is it clean? No. So there also you need some processing. So you need to add some elements to generate the energy. Okay. So if you want, means we can talk more than 1 or 2 days based on second source, nuclear. What is plutonium? What is uranium? What is thorium? How can you convert thorium into your this one? So there is a huge area nuclear energy. Okay. Yeah, wind power, yes, it's a clean. Do you agree? Wind power is a clean. But ground solar, yes. Hydro, yes. Biofuels, space one, yes, it's a clean. I mean, there is no additional process required. Clean in the sense, there is no extra cost involved. There is no extra investment involved. That's what I mean. Yeah. Hydropower, yeah, it's reliable, yes, complex scheduling. Hydropower means you have to generate power from hydro plants actually. And one more tidal I missed in this, tidal power. What is tidal energy? Tidal. We have longest coastal area, right? Towards eastern side and towards western side. So you will have a lot of waves. Okay. So from that also we can generate the energy, tidal plants. So that is also a clean source. So that is somehow it is done. Anyway, the thing here is, you see the last row, the table last row. All are no, right? Yes. Right? Last row, all are no. Solar power is not clean. Solar power is not viable, not reliable, right? Yeah. Okay. That means solar space, that is space-based solar is completely clean, completely safe, completely reliable. We can depend on that, and it can take loads, it can take base loads. Okay, it can take n number of loads. Okay, you got the point?
Yes, sir.
Yeah. Now only, I mean, our actual presentation is starting. Introduction to our core area of this FDP session, space-based solar power generation. Okay, so don't ask me after 10 slides again you will find introduction. Okay, okay, fine. Let us see. Yeah, space-based SPSP is the concept of collecting solar power in space using an SPS, space-based system, space-based satellite, space-based station. Whatever you say. That is a solar power satellite, or a satellite power system, or a solar power station, I will call it. Okay. So this is to use this power on Earth. It has been researched way back 1970s. It has been started way back 1965, 68, somewhere around. And the raw work, the actual work started somewhere around 1970 as per Wikipedia. I took this data from Wikipedia. And don't ask me how can you say from Wikipedia. Okay, good. How it would differ from other this one? How it is different actually? Okay, whatever we discussed, solar-based like space-based solar power would differ from current solar collection methods. In that, the means used to collect energy would reside on an orbiting satellite instead of on Earth's surface. See, today what I am doing for solar power generation for PV cell, what I will do, I will construct one house. On rooftop, I will put one solar panel. I will design my own PV cell by taking the area of my rooftop available. Okay, so if I am rich enough, I will construct some half-acre building. Okay, I will put solar panels. If I have some 20 acres of land, I will put solar panels for 20 acres. I will generate power. That power I will give to power grid. Power grid. So from the power grid, power will be transmitted. From power grid, power will be given to different stations, power stations. From those power stations, we will get the power connections for the individual applications. Whether it is a home application, whether it is a charging station, like you told, e-vehicle charging station, or whether it is a one marriage hall to be lighted, some 2 nights. To take some power from solar grid, understood? Or largely you can run one industry, you can run one factory from taking power from solar power grid. Okay, so that is the existing method. So where I am putting my solar panel, one is on the rooftop, second on the land, third maybe on the moving vehicles also. All buses maybe today they are having solar panels on the top. Even some trains, even some conventional cars also they are putting with the solar panels on the. So these are the ways where I am installing my PV cells, photovoltaic cells or solar panel shortcut. Okay. Now, where I have to put these solar panels? If it is in the space, you tell me. On Earth means I have my house. On my house I will put solar panel. In space, where will I put? Satellite. Okay. Satellite where you will put? Okay. I'm getting good answers. So we can place satellite in orbit. Okay. What is orbit basically? Okay. I also studied my social studies back in 1997, 1998. Okay, good. Okay, just try to recollect your social studies. So there will be a sun. There will be a circles around the sun. Okay, so that is called orbit. And we can place satellites in the orbits. Okay. So to cover completely, we have to place each satellite in the orbit with some angle. Okay. So yeah, like that. Okay. For example, how my mobile is working, how my TV is working at home. So there is a satellite. Okay, which is receiving video inputs from the base station. Okay, say Gemini TV for example, or ETV, whichever you like serials for. Take ETV. Okay, so from ETV, how I switch on the TV, if you put channel, ETV is coming. How? So there is a base station in Hyderabad, whatever is that Somajguda, whatever I don't know. Okay, so from that earth station, they are doing some program. So that program will be captured. That program will be transmitted. Okay, through some link, radio link to the satellite. In the satellite, in the orbit, there are two things: receiving antenna, receiver, and transmitter. So receiver will receive this video input that will transmit whatever received through the transmitter. So again, here and there are some big antennas. located in Palamaneru, Chitturu, whatever, Vellore, whatever is there. So from those towers, I can say mobile towers, TV towers, whatever you see. So from the towers, signal is transmitted. Whatever antenna you are keeping on the top of your house, okay, so that antenna will receive that signal, that will be given to your TV for the display. Okay, so there are two types of PAL, PAL, CCIR. Where we don't go to more technical details. Okay, so there is a uplink, downlink. There is a frequency band to transfer this video signal from base station to satellite. Now, I'll put one satellite so that you can see only TV during night, or so that you will see only TV during college time. Okay, so that you can't see. TV is there, but you can't see in the night. Only daytime is possible. Daytime college is there. You can't see that. Now, to avoid this, I will put 3 satellites. Okay, so 1 watt duration, 1 satellite will work. And the switching of the power, switching of the action from one satellite to other satellite is also fixed actually. Okay, so these 8 hours, 1 satellite, another 8 hours, 1 satellite, another 8 hours, 1 satellite. So those who want to see TV 24/7, you can see. Provided power should be there. Provided power should be there. If no power, you can't see. Right? Okay, why this point here? Yeah. Okay. Yeah. If you see, now where to put this solar cells? I got the answer in the orbit. Okay. Where in orbit? Satellite. Any such thing happened as of now? As of now, any such thing happened? Yes. Yes. Your Sunita Williams, right? Sunita Williams. Who is Sunita Williams? Astronaut. Great. Okay. What she released one video recently from ISS, International Terrestrial Station or Space Station. Okay, ISS. Okay. Now, space station. What is space station? Okay. I got a doubt. See here, my solar cell or PV cell, I have the pillars for my house, so my building is strong enough. If you put 10 solar cells, PV cells, or 10 panels, 50 panels, my pillars of the building will stand. Okay. How there will have? You have any pillars there? How it is standing there? There is no gravity. Wow. Okay. What is gravity now? Okay, good. Very good. Go through the Sunita Williams madam's video. You will understand gravity. That's why I told. There is one short video released recently from ISS. So you see that how the gravity works. How gravity works. You need not to walk there. You need not to walk there. Okay, you can fly actually. You can fly even though you don't have any wings. Right? Okay, good. Am I boring? Good. Yeah, coming to our point, where to put this satellites or where to put this solar power station, I'll say space-based solar power station or space-based solar plant, I can say. Okay, where to put in the orbit. Okay, now we will discuss how it has to be put, with what angle, how to design that angle with respect to sun rays, and first of all how to collect this sun rays, we will see quickly. Okay. Yeah, coming to this picture, bottom side of the slide. Yeah, my second statement is higher collection rate and a longer collection period due to the lack of a diffusing atmosphere and night time in space. Yeah, in Earth means during rainy season I don't get solar rays, sun rays. During nights, I don't get sun rays. During winter season also, I will get only limited sun rays. Okay, as you all know. Now, in space, you don't have all these problems. 24/7, free of cost, available. Normally, free of cost means that will be standing first, including me. Yeah, it's true, right? See, why I came here? I didn't come free of cost. I'm paying. I was paid by the college. Okay. So for the FDP also, it is not free. You will be paying, or your college institute will be paying, right? Or AICTE will pay to the college, if I am not wrong. Okay. So if anything is freely available, We are the people who are standing first. I want the same thing in solar, space-based solar also. Since space-based solar power is free of cost, we all should work towards that. Since it's a free of cost. Yes, it's true. Do you agree or not? It's true. We are spending crores of money in making nuclear reactors. You know, to make one nuclear power reactor, how much it costs? It runs into tens of crores. And you know how much of money spent to maintain that nuclear power reactor? It's a huge cost involved. And you know what is the amount involved in refining plants or crude oil to your clean petrol is coming out. A lot of crores is involved. And how do you transfer these sources from one station to other station? Lot of digging canals, putting pipe, lot of investment, lot of maintenance charges are available. We are spending crores of money, right? We want the same seriousness, the same amount of funding for this space-based solar plant also. That is the point I want to highlight. Since it's a free of cost, right? Okay, good. Yeah, space-based solar panel, like rough calculation. If you take this one, the intensity of the rays which are coming, solar rays, the intensity of the solar rays, the intensity power, it will be not same to the one building which is of 2 floors, other building which is of 20 floors. The solar intensity is differs. Agree?
Yes, sir.
Agree?
Yes.
Now, you see the solar rays intensity in space. Right. Much more. It's a very high. Because in between there are some losses. In between there are some diversions. In between there is a traveling distance is more on Earth. Right? From Sun, it has to reach Earth. There is a lot of time, lot of distance. If you think space, okay, you will get a high intensity of solar rays. What does it mean? You will generate more amount of energy, right? You will be capturing highest amount of energy from the sun rays, which are coming with high intensity. On ground, to measure that, you are putting one lens on the paper. You have to wait for 1 or 2 minutes. In space, nothing is required. You go there, you board yourself. Right? Yes, we have to design our hardware, our satellites, our space-based power system, such a way that it has to withstand highest amount of heat it has been faced off. Right? You have to use that much highly qualified materials, highly qualified electronics, highly qualified small cables. Okay? Why some of your charging cables are burning? Right? You see in space. Okay? That means the seriousness here involves the design of hardware for the space-based solar power generation should be of, it is of challenge. It is really of challenge. Okay? So very carefully you have to take decision which material you want to go to, you are going to be used. Once you put in the orbit, then whatever time you wish, you cannot call it back. Okay? So if any your design caters for reusability, maybe you can call it off, you can do it, you can do some maintenance. Again, you are going to put the satellite in the same orbit. Okay, again there's a design challenges are there. Lot of design challenges are there. It's not so easy. It's not casual. It's a very serious developing a hardware to meet the space requirements. Right? Since the intensity of the solar rays is very high. If you take one solar panel, approximately you will get 1366 watts per meter square. That means if you use 1 meter by 1 meter solar panel, so you will be receiving power 1366 watts. That means 1.3 kilowatt. Okay? Yeah. No light. minimum weather, I mean in the solar this one. Coming to ground solar, the bottom row if you see, solar intensity less than, obviously it's a less than so space in this one. Night maybe less, losses are more, okay? And the weather loss also like more on earth. So all these white color gaps in the bottom row are not there in the space. So that's the point here. Yeah, like your history, like your introduction, one more thing, basic concept. Okay? Now we are entering into actual concept. Okay, basic concept. As part of the solar energy, solar energy is lost on its way through the atmosphere by effects of reflection and absorption. There are two things, reflections and absorptions. There are clouds in between. Obviously, some amount of the intensity will be lost from the solar rays while you are receiving on the earth. There are some reflections in the sense, for example, what is reflection basically? If you put some glass, if you put some mirror, okay, so there is some light ray, put light ray on that mirror, it will get reflect. Okay, you go and stand in front of the mirror. What will be there? Your face will be reflected, right? Yeah. So the point here is there are things like reflections, there are things like absorptions. Due to this, the intensity of the solar rays will be less on the earth compared to on the space. That's the point. Space-based solar power systems convert sunlight. This is the basic concept. Convert whatever you are telling satellites, whatever I am explaining, solar power generation stations. Solar power station. So SPN I use, SPN, solar power station. This SPN or SPS, so solar power satellite or system, whatever you say. So what this will do, this will convert your sunlight into microwaves or laser beam outside the atmosphere. Outside the atmosphere. That means the space. Avoiding the losses like absorption, reflections, and the downtime. That means you need some time to reach sunrise from sun to the earth. You need more time to the earth compared to space. Okay? There are something called cosine losses. I tell you what is cosine losses. Okay? Cosine losses in the sense. Okay, we'll discuss this later while designing this satellite. That will come that time I will explain. Now, how you are orienting towards sunrise, that leads to this one. How accurately you are orienting your mirrors, you are orienting your satellite towards the sunrise. So, there any degree, any angle changes means obviously this cosine losses will differ. So, the amount of cosine losses with the orientation of theta 1 degree and the amount of cosine losses with orientation of theta 2 degree is not the same. Okay, so your design should cater for proper alignment, proper line of sight with respect to sunrise. Okay, that's the thing. Okay, right. Again, history is coming. Okay. Again, history is coming. Anyway, this I don't tell you. Some factual things. Okay, maybe last 2 days would be covering these points. Like what happened when all this 1970, 1990, NASA, USA, Japan, China, all these things. Okay, some history facts again based on Wikipedia. Okay. Now we understand why this space-based solar power is required. Clear? Everyone? Anyone not clear? Anyone not clear? So we all want space-based solar power. Why? Since it's free. It's a free of cost, right? Okay, good. Am I serious? Yes. No, right? Am I boring you? No. Right? Okay, good. Sometimes you have to bear with me. Some repetitions will be there. Last 2 days, the same faculty would have repeated this yesterday, day before yesterday. So again, you have to please bear with me because I don't know what was spoken last 2 days. Fine. What are the requirements of what are the requirements to get this space solar power. Why we have to go this? What are the requirements? Anyway, again, interested and explains in detail. Since it is a low cost, environmental friendly, launch vehicles. What is this environmental friendly? Environmentally friendly. What is this? Carbon emissions. Okay, so greenhouse effect. So we are discussing lot many things, right? Carbon emissions, greenhouse effect, space-based solar energy, fossil fuels, right? Sustained investment, capital, revenue, right? Okay, good. I am capable of teaching MBA students also. Good. I appreciate myself. Okay. Yeah, large scale in orbit construction and operations. To gather massive quantities of energy, solar power satellites, SPS, must be large in the sense like area wise and quantity wise also. Right. For larger than the International Space Station. Say for example, ISS may be in the size of your college. Okay, International Space Station may be the size of your college. I also not seen. Just I'm telling. Okay. Now your solar power station, it must be larger than a space station, or it must be lower than space. ISS area wise. Area wise, it must be larger. Why? It will receive more number. It has to receive more number of sun rays. It has to generate high amount of energy, right? Agree? So now you say International Space Station (ISS) is larger or space-based power station is larger? So we are larger than Sunita Williams. Understood? Agreed? Agreed, right? Yeah. Good. Why? I answered already. Why we should be larger? Okay. Power transmission. To transmit the power from satellites. See, I will be using these two terms alternatively. Satellite or space-based solar station, both are same only. You think it that way. To Earth's surface with minimal environmental impact. Okay. Requirements for space solar power. I will continue the earlier slide. Low cost, same thing. Large scale orbit construction operations. Okay, to gather massive quantities. Okay. Fortunately, solar power satellites will be simpler than ISS. Yeah, very important statement. We are area-wise, we are bigger, larger. We means who? Space-based solar power stations. We are bigger than ISS. We are simple than ISS. Simple in the sense design point of view, right? Sunita Williams is there. She has to take care of gravity effects. Otherwise, she will die, right? So, in our this one, there is no human involved. That means design will be simpler. Agreed? Yes, sir. Yeah. How it works? Now we understand what is space solar power, why it is required, what are the basic concept. Now we came to a point how it works. Very important thing. How it works. Okay. Yeah. Now, before that, I will explain my house. On my rooftop, I placed one solar panel. Okay. I called one guy who is giving solar panels at lesser cost, subsidy cost, no free of cost, subsidy cost. See why I am stressing this point, free of cost. You have to think space. Sun rays are free of cost. You have to think importance of space solar. That is my point. Okay. Now, government is giving lot of subsidies for using this solar panel. Solar energy or solar power plant, solar power generation. Whatever government is giving, very good number of subsidies. I want each one of you will have one solar panel on your house. If you have the roof, I know everybody is having the roof. Okay. Right. That's the importance of this one. Okay. Now I have the solar panel on my rooftop. What I am doing, from the solar panel, from PV cell, I'll say that's a basic PV cell. From the PV cell, I'll connect two wires. Okay. So whatever generated energy, that will be, I have the batteries. so that batteries will be charged continuously whenever the solar panel is giving the energy. So from the charged batteries, I am connecting the loads. Okay, your basic understanding. Load means your mobile charging is also one of the load. Okay, you are putting TV on, one of the load. You are switching on all the fans, lights, one of the load. Okay, all these are loads at your house. At your house. Okay, so this is how it's working. This is how I am using. Now you understood. Solar panel is there on the rooftop. From solar panel, power is generating. So with the 2 wires, basic understanding. With 2 wires, I am charging my batteries. From the batteries, power is given to the loads. Okay. Now come to our station. Okay, solar power station, how it works. Space solar station, how it works. Okay. Here means if rooftop panel is there, it will receive. Okay, so design is simpler. PV cell, very simple design. Even not MBA, even 10th class student can design. Nowadays PV cells, very simple design. Okay. Now coming to space-based power station, how it works, how to design. Okay, that we will see. The radiation, solar panel equipped energy transmitting geostationary satellites located above collect high intensity uninterrupted solar radiation by using giant mirrors to reflect the huge amounts of solar rays onto smaller solar collection. Okay, don't go all this. I'll tell you in a simple way. Okay, assume there are 2 mirrors of size this room. 2 mirrors are there. Okay, what I am doing? I am putting 2 mirrors like this. Okay. So like this I am putting mirrors, 2 mirrors. Very giant mirrors means you assume 1 mirror of half kilometer size. 1 mirror of half kilometer size, the diameter. Circular mirrors. Now sun rays are coming and falling onto mirrors like this. Okay, right? So whatever sun rays are coming and falling in the mirror, it will get reflect. This will get reflect both mirrors. Now in between I will put another mirrors so that it will receive. Okay, so these are giant mirrors and others are receiving this one, right? So from the reflectors, okay, I will convert that light energy or rays, sun rays, I can say, right, energy into different mode of energy. I'll explain what is different mode of energy. Then that energy I will pump to some other equipment, some other hardware. That hardware will receive that energy. Through that hardware, using wireless means, I will transfer that power to earth station. On earth, again I will have the antenna, say of size 20 kilometers. Just to assume, since we are getting power from space. Okay, say you have the receiving antenna on earth, say 1 kilometer. Okay, we will start initially less about this. 1 kilometer. So 1 kilometer radius of antenna, it is receiving the energy coming from space. From this antenna, 1 kilometer radius antenna, I am getting the power to the grid, power station grid. From the grid, power grid, again the process is same. Whatever you are following nowadays. From the power grid, power will come to the power transmitting station. From power transmitting station, using wired or using wireless, you will be transmitting power to the individual loads. What are my loads here? Industry, charging station, house, or an office, or a vehicle, whatever is. Okay, so this is how it works. Now, how to design these very big mirrors? How to transfer the energy coming out from these mirrors, okay, to the energy collector there itself. From the energy collector, how to transfer the energy to the earth wirelessly. Okay, so that is challenging. So it is like everywhere challenge is there. Every point is challenge is there. Design of this giant mirror, it itself a challenge. Right? For example, you assume some cameras. In camera, there will be mirror. Okay? So you assume, so that mirror will be moving. That means you are not moving camera up and down. You are only operating one switch. So with some slide bar, that mirror is moving up and down. Wherever you want, it is pointing, and it is collecting the video or camera, whatever is there. That means that the mirror you have to design very carefully. Okay, where you want to see, there only that mirror should look. Okay, that means your line of sight, mirror line of sight should match. Okay, so here lies control system. Here lies sensors. There is a small sensor which tells us at what angle my mirror is now. Like a zero, like accelerometers, you know, and what position my mirror is, position sensors again. Any deviation is there in the mirror, natural oscillation, that we should control. So to control this natural oscillations of the mirror, I will have a closed loop control system. It looks very new, but still, for a basic understanding I want to tell. So this closed loop design, closed loop control system, again design of closed loop control system, it needs some time. We have to simulate in the computer, we have to feed input, we have to get the output in simulation without any hardware. And whatever input I am giving, I should get the same output. Once my simulation is perfect, once my simulation is correct, then I go for the hardware manufacturing. Okay, so where I am, I am talking about mirror in camera. That means very precision control of mirror movement is required. That is my point. For small camera, now you tell me you are using half kilometer diameter mirror. You should control that, right? I mean, you should control such a way that it has to look there only, where it's supposed to look. That is called LOS, line of sight. Okay? Otherwise, what will happen? I am putting two mirrors. So both mirrors should be in the line of sights for which they are designed. If any change in the angle theta, the amount of sun rays collected will differ. Once this will get differ, the amount falling in these mirrors, the reflected this one, that also will differ. The amount of energy generated will differ. Everything goes, out of your expectations. Am I right? So the design of these mirrors, placement of these mirrors, and controlling of these mirrors, these are all challenging points. Okay, there are a lot of electronics involved in this, a lot of controls involved in this, lot of mechanical design involved in this, lot of optical design involved in this. So space-based solar generation, it is a multidisciplinary mission, I can say, multidisciplinary mission. So there are optical engineers who are designing these mirrors, and they know what is my coating, what is my coating on the mirror. You are seeing mirror in your house. What is the coating? What is the material used for the coating? What is the standards? What is the internationally accepted standards to use this coating material? What is Indian standards are available, like that. So each and every time we have to refer the acceptable standards, approved standards. As per that approved standards only, we have to design the things. If you are going out of that, the result also, you are moving out of the required window of the results. Your design is not in the specified window, means your output also, it may not be in the required window. Getting my point? Yeah, where are my mirrors? So optical mirrors. So optical mirrors we have to design. Then the reflectors also we have to design. Then the receivers, energy receivers, transmitters, everywhere we have to design carefully. After 5 minutes. Yeah, now we are how it works. Yeah, still we are at this slide. How it works. Yeah, solar panel equipped energy transmitting geostationary satellites located at above current high intensity. Uninterrupted solar radiation. Good. This radiation is then wirelessly beamed to Earth in a safe and controlled way as either a microwave or laser beam. Okay. Yeah. Now camera. So camera lens design. You feel you see you think can you protect camera or any some recent camera. Kodak means old, very old application. Okay. So there we have the analog designs. Okay. But now all small cameras have come. Okay. Your mobile also there is a camera. Your mobile there is a sensor. Gyros are there. Accelerometers are there. Your mobile also touch sensors are there. Whether your screen is capacitive or inductive, what type of touch technique is involved. Okay. So all everywhere. So a small mobile itself is a complex design. You think this much big solar, space-based solar system, how complex to design. It needs years to design. It needs lot of hardware. It needs lot of simulations. Okay, so it's not a simple thing. Okay, lot of work people are doing. Lot of work involved. Okay, lot of scope is there. So lot of scope is like a very huge area, space-based power generation. Okay, yeah. Okay, we'll just stop it here. We'll take a break. Okay. So if I am boring, please tell me. Then okay. So okay. Good.
ஹலோ க்ளோஸ் வச்சுட்டு இப்படி யூஸ் பண்ணிங்கன்னா நீங்கள் வெளில ஸ்டூடெண்ட்ஸையும் வாட்ச் பண்ணிட்டு பின்னாடி பேசலாம். நீங்கள் அங்கேயே இருக்கணும்னு ஆசைப்படுவாங்க பேசுவாங்க.
They also feel they are comfortable.
பரவாயில்ல, நீங்கள் வந்தீங்கன்னா தான் நல்லா இருக்கும். ஓகே, கம்ஃபர்டபுள். பேசி பாருங்க. நீங்கள் க்ளோஸில் வச்சுக்கோங்க. இன்னும் கொஞ்சம் க்ளோஸில் வச்சுக்கோங்க. அங்கே இருந்துட்டு பேசணும் இல்லை. நீங்கள் மேபி உங்களுக்கு கம்ஃபர்டபுளாக இருக்காதுல்ல?
So you are from which PG? No, which one? PG. Which power systems? What all subjects you are studying? What are the labs?
Okay,
What are the software you are using? Simulation something. Where you studying now? It's Anantapur, JIT. How many of you are there from JIT? Power systems. See, since some MBA things also there, so yeah. No, that's why my presentation mixed. Actually, I thought of, no, I am not from, I am pure technical guy actually. So, somehow, is it okay? The section is going well?
from past 2 days to same stuff is happening. I mean, they are saying stuff.
Okay.
So we are little bit boring.
Yeah, I understand. Yeah, these things we will discuss there.
Past 2 days to the same thing. We are technical, so
Okay.
we want some idea about that.
Okay. Okay, then I'll try to cover some. What's your name? Aisha. Ekada? I studied like that. Yes. So, madam, you are from which college? That's the same college. Power systems. So, you are powerful. Power systems, powerful. BTech education. You? Thanks. Thank you so much. Sir, no, I can't.
Please check once. Whether it's playing or not. நீங்கள் இதை மட்டும் சொல்லுங்க, நான் பார்த்துக்கிறேன்.
Yes, I can't.
ஓகே.
So, madam, you are from which college? Same, correct? BTech ekkada?
ఆర్యాన్ని చేసేసి
Palamaneru.
నంద్యాల సార్ కానీ అక్కడ
Correct. Correct. That's what it is.
తెలుగు
Tamil తెలియాలా?
మాట్లాడాను
తెలుగుమా?
కొంచెం
How? Me? Okay. ఎట్లా ఉంది session? పర్లేదా? పోయిందా? Some videos will play.
అంటే సేమ్
Repeat అవుతుంది. Last 2 days ఏం డిస్కస్ చేసామో అది repeat అవుతుంది. We'll go out of syllabus. We'll go out of syllabus. మీరు ఇక్కడే చూస్తున్నారా? సారీ, మీరు పార్టిసిపేట్ అవుట్ సైడా?
అవుట్ సైడ్ సార్,
అవుట్ సైడ్ ఎక్కడ?
అనంతపురం సార్,
చూడు ఎక్కడ ఏ కాలేజ్?
జేఎన్టీ ఇంజనీరింగ్ సార్.
ఓకే. సో అంటే ఎట్లా అంటే ఎంబీఏ అంటే వాళ్ళు కూడా రావచ్చు అట్లా అంటే ఐ మీన్ ఐఎమ్ ఆస్కింగ్.
అంటే ఎంబీఏ కాలేజ్ సార్ వాళ్ళు తీసుకున్నారు.
ఓకే. అచ్చా, ఎంబీఏ డిపార్ట్మెంట్ తీసుకుంటారా
సార్
ఎంబీఏ స్టూడెంట్స్ కాలేజ్ ఈ కాలేజ్
ఈ
వాళ్ళు?
కాలేజ్ వాళ్ళు
ఓకే. పార్టిసిపెంట్స్ ఎంతమంది యాక్చువల్గా?
మేము 12 మంది, వాళ్ళు 20 ఉంటారు సార్.
ఎవరు?
ఎంబీఏ వాళ్ళు.
ఈ కాలేజ్ వాళ్ళ
లేదు సార్.
వాళ్ళు పార్టిసిపెంట్స్
ఎస్ సార్.
ఎఫ్డిపి.
ఎస్ సార్.
ఇది టెక్నికల్ కదా ఎఫ్డిపి నార్మల్గా ఇది ఎస్ మేడం. మీరు ఎక్కడ ఏ కాలేజ్? సేమ్ సేమ్ కదా. సో బీటెక్ ఎక్కడ చేశారు? మీరు సక్సెస్ అయ్యారు సార్. ఇద్దరికి ఎక్కడ ఏ డిపార్ట్మెంట్? కుమార్ ఐఎన్జి కుమార్. So we'll discuss some out of syllabus topics. Shall we discuss some out of syllabus? Last 2 days we are listening to solar power, some more than 1,000 times. Right? Going back, we'll discuss some out of syllabus. No, I want value for the concurrence. Okay, welcome. After the break, we'll discuss the process will go. So normally, how many R&D organizations are there in India? Research and development institutions owned by government of India or good private sector also. Any idea? One is DRDO, ISRO, Bharat Biotech. Okay, good. NARL comes under ISRO. NARL, you have seen all the antennas? Friday. You see more than 1 kilometer. You ask them to take you there. There is a large area you can find antennas. NARL, very good facility. I'll come back to you. Okay, so there are premier R&D institutes in India is out of syllabus based on the candidate's interest and discussing. Okay, so DRDO, ISRO and CSIR. Okay, CSIR, like basic sciences, chemistry, physics. And how do you know this is the 1 liter milk? How do you know this is the quantity is a 1 liter milk? Using weighing machine. So that is okay. Gently you put, where you put? There is a mark, 1 liter. Then how do you guarantee that is the only 1 liter mark? I put the 1 meter above one more mark. You will measure. No, that is okay. 900 ml. 900 ml 1 liter. Okay. 1000 ml. Okay. I accept all answers. Okay, fine. There is an institution. Yeah, listen. Tell me what? Okay, how do you know this is 1 kg of weight? This is the amount of 1 kg of sugar. This is the 1 kilo. How do you know? Weighing 1000 grams. Okay. How do you know this is 1 gram? That is okay, ma. Weighing measure. Okay, so how do you know 1 kilo of sugar? I asked you. Like who will tell this is the amount of quantity? This is 1 kilogram. Who will tell? Okay, weight that everyone knows. But how do you tell this is the amount of quantity 1 kilo? Okay, now you talk about 1 kilo of gold. 1 kilo of gold. This much gold is 1 kilo. How do you tell? Value estimate. Okay. Okay, I asked you 1 liter milk. How do you tell? 1 kilo of gold. How do you tell? Okay, there is a laboratory at Delhi, National Physical Laboratory, which works on basic sciences. So they will, they are deciding authority in India with respect to all aspects, gravity aspects, all with respect to this one. They will have the reference missions. So there they will decide this is the reference. This is the reference of quantity of 1 milligram or 1 gram or 1 liter or 1 mm, whatever all your measurements, physical parameters. So this is this is the 1 pascal of pressure, and all these things will be like reference. There will be a reference parameter. With reference to that, you are weighing or you are weighing milk or gold or whatever is there. Okay. So how do you know from here to main road half kilometer? That half kilometer again 500 meters don't tell. Okay. So that 500 meters, the distance also, this is the only 10 centimeters. This is the only 1 centimeter. I will tell this much is 1 centimeter. There should be some reference, right? So that reference is at the National Physical Laboratory, Delhi. So they are working on basic concepts like this is the amount of quantum of water 1 ml. This is the 1 milligram of this one weight like that. Okay, just for information I am sharing. Okay, now. Yeah, National Physical Laboratory. Why this scale? Yeah, R&D institutes in India. So DRDO, CSIR, BARC. What is BARC? Baba Atomic Research Center, Mumbai. Department of Atomic Energy, DAE. So we are also one of the premier R&D establishment. TIFR, Tata Institute of Fundamental Research. Who is doing supercomputing in India? The fastest supercomputer in India. Who is doing? Again, TIFR, Pune, Tata Institute of Fundamental Research. Okay, so like that, there are some very good private R&D bodies also there. Okay, so if you take any private company, they will be having one R&D wing, research and development division, R&D wing. So there they will be working on core concepts, R&D concepts. Okay, now, R&D institutes in India. Now, I am from DRDO, one of the institutions I am from DRDO. Earlier I worked with another R&D application, DAE, Department of Atomic Energy, for nuclear power reactor, ECIL. Okay. Apart from R&D institutes, there are also some PSUs. What is PSU? Public sector units. Okay, like your BHCL, like UPL, HAL, many are there. Many are there. Many are there. Okay. Then, apart from PSUs, defense PSUs also there. What are defense PSUs? Purely public sector companies which are mainly for doing the production of arms and weapons, weaponry. If you want some machine guns, what are the types of machine guns? AK-47, LM, light machine guns, carbon machine guns, munitions, hand grenades, okay, bombs. All these manufacturing of 1,000 bombs, manufacturing of 10,000 AK-47 guns, for example, manufacturing of 100 number of missiles, manufacturing of 200 numbers of main battle tanks, for example, okay, or some combat aircrafts, okay. To do production of these weaponry systems, there are defense PSU. Public sector units comes under defense, okay, BPSU. Okay. Now, coming to what we tell. Yeah, I talk about my application for 5 minutes. Okay, is it okay for you? Out of syllabus. Okay. Yeah. We work on battle tanks. Battle tanks. Okay. For example. Yeah, I will play some 2 minutes video. Screen is less now. Don't blame me, it's a YouTube video. This will close it. Yeah, now it will be proper. Okay, how many of you interested to work in India? First of all. I repeat the question. How many of you are interested to work in India? No, I didn't ask all, I asked you. Huh? So each one of you are interested. A few are not interested. USA, Germany, Japan. Now question comes. Why you want to work only in India? Why you want to work only in India? Next question. Huh? India is rich. We need to work for our country. Valid answer. Yeah, now coming to DRDO, Defense Research Development Organization, what we will do? Yeah, I'll explain for 5 minutes. Okay. So what we will do, as per we will do what are the weaponry systems required for Indian Armed Forces. Who are Indian Armed Forces? Indian Navy, Air Force, and Army. Okay. Now there are few DRDO labs working for Indian Air Force, a few labs working for Indian Army, few labs working for Indian Navy. Okay, so Indian Navy mostly what are the products, list of products, warships, underwater missiles, okay, sonars, all this comes under Navy side products. Coming to Army, what are the different products Indian Army? So battle tanks, missiles, then many are there. Many are in the sense like machine guns, small arms, medium arms, okay, with this grenades, everything will be there. Motor means based on your this one on arms you will be firing. Okay, motors actually. So then coming to battle tanks. Okay, what is the different kinds of battle tanks? Okay, different country will develop different types of battle tanks. Okay, for example, China if you take. China will be developing battle tanks different series. Like Russia will be developing T series, T90, T72, T55 like that. So Russia will be type 99, type 98, type 89 like that. So our Indian made battle tank name is Arjun Mark 1 and Arjun Mark 1 Alpha. Okay. So that's what we are doing at Chennai, Avdi, Chennai. So what is Avdi? There is some full form is there. Avdi is the name of the place, but still there is some full form. Avdi, armed vehicles, like ammunition, armed vehicles and ammunition depot of India. Avdi. That is a full form. So it's the name of the place only, but there is a purpose why they named that place actually. So all the ammunitions will be stored. All the ammunitions will be placed one place during World War 1, 2, whatever it is, China War, Indo-China War, Indo-Pak War, those times. So the place where you are keeping your ammunitions actually in India. Overall ammunitions requirements to different parts of India will be from one point actually. So that is this one. Okay. Now I should not tell this. Okay. Anyway, now it is not one. Many are there. Okay. Not Avdi, different things. Okay. Good. Now. Coming to Arjun, what is Arjun main battle tank? So they are developed by DRDO. There will be like 4 members in Arjun tank. 4 members means crew, tank crew. Gunner. Why gunner is required? Why gunner is required? To fire. Right? To fire the targets. Who are our targets? Enemies? Neighbors. Okay. Neighbors are our targets. Good. Okay. Who are our neighbors? Pakistan, China. Okay. Now, before designing your battle tank, you have to study neighbors also. What kind of battle tank they are using? What kind of missiles they are having? What kind of weaponry they are using? Based on that, we have to design our own weapons also. Okay. Now, there are 4 people I told: driver to drive the tank, gunner to fire the ammunitions, Commander to locate, to drive, to guide driver, a commander. So driver, gunner, commander, and fourth person will be the loader actually. So loader, what he will do? He will load the rounds, bullets into main gun barrel. Commander, what he will do? He will use the GPS and he will guide the driver how to move from one place to other place using the map actually. There will be a map, grid map actually. So here you will find very good boards, Palamaneru, Chittoor, like that. If you go to desert area where Jaisalmer, where there and all, you don't find any signboards. You don't find any mobile towers, or you don't find any things which are identified. It's completely desert. Desert means you don't know where you are sometimes. Sometimes we'll go for nighttime firing. We'll go some 20 kilometers far from our stations. So morning 4 o'clock while returning, it is not guaranteed that we are returning to our own station. Sometimes you may reach your neighbor station. What will happen? Yeah, so that's why GPS is very important actually. So commander role is very important. One should have what I told. Your GPS, your moving of your weapons is very important actually. That means all your sighting systems which are used for your weaponry should be very precise. That means that a sighting system you can see here. Gunner's main, it is called gunner's main sight. Yeah, can you see this one window? So this is gunner's main sight. Through this only gunner will be seeing the outside. So there is a CCD camera, charge camera is there for day vision. For night vision generally what we will see night time. What are the sensors we use night time? For night time, what are sensors we use for vision purpose? Night vision devices, right? So there are thermal images. So thermal images, how they work? Thermal images based on your image intensification principles, based on your the temperature differences of, if you take any two block bodies. So each body will be radiating different type of temperature emissions. So if you take the difference actually, there are a lot of detectors actually. Okay, so the detectors will sense the differences in the temperatures on each every plane. So it will form the thermal imaging video or thermal images for nighttime vision actually. Understood that? So the first generation, second generation, third generation. So we are using third generation thermal images for nighttime vision. Not only we, even other Russian, German, they are also using third generation TI thermal images. It's like electro-optic sensors actually. So what is thermal image again? So how we create? It's a black and white image. It's a black and white image. So through that we will be identifying whether it's a battle, battle tank, is a lorry, is a jeep, or is a human. So by using the different patterns, we will be identifying targets. So if any threat is there, we will be firing the threat immediately without the delay. So if you delay, what will happen? Okay. Before firing enemy, what should we need? The signature, thermal signature, number one. Number two, what we need? Okay, you are firing one person. What you should go first? You should do the distance first, right? Na? So the range, how do you find range? Using again, there is sensors for knowing the range. Laser range finders are there. LRF will tell. Laser range finders. Two types are there. I-safe for LRF, non-I-safe LRF. So I-safe, what is I-safe again? While you are operating a laser range finder, any reflections coming in the sense, any reflections. So there is no damage for your eyes. Non-I-safe means there will be threat will be there. You should take care. You should use goggles. You should put safeguards while using non-I-safe lasers. Okay, laser range finders. Why laser range finder? To know the range of the enemy. How do you know this? You will send one laser pulse. Okay, laser beam, laser pulse. So that will go and hit the target and it will come back again, reflected again. You know the time. You know the speed. Now you will calculate the distance. So within fraction of seconds. Okay, you will be having a laser transmitter, you will be having a laser receiver, and you will be having an electronics unit which calculates the range. Okay, you know the range, you know the thermal signature, right time I am telling. You know there is a threat actually. So immediately you will align the main gun. So this is the main gun. You can see here now. You can see here this one. This is the main gun, around 7 meters length actually. 120 mm barrel actually, diameter of the barrel. So that main gun, you will be aligning towards the center of the target and you will be firing. Before firing, what we should do? We will ensure the safety aspect, we will ensure the ammunition loading aspects, and then we will ensure the readiness of our system, safety of our crew. Then we will fire. Okay, per minute we will fire approximately 8 to 10 rounds per minute. Now, here, first round you are firing, it missed, what will happen? You fire first round, one round, it missed, what will happen? He is also having time. Whether he will stay calm, he will fire back. That time what will we do? That time what will we do? Change position. Good. Any other techniques? That's what we'll do. Protecting. Yeah. So there are some techniques for protecting our own tank. So what we will do? We will fire the laser grenades actually. Smoke grenades. Smoke grenades we will fire, and to create a different type of pattern, smoke layer, very thick smoke layer around 20 meters, 30 meters, like in front of our tank. So by the time the smoke layer will evaporate, you will be shifting your position from one place to other place. Okay, now to avoid this condition, what we should do? What condition? Expecting hit from enemy. To avoid this, what is required? What is required means first round hit probability should be 100%. You understood? You fire means he should die, or he should get casualty. That's all. He should not fire back. So up to that extent, you should be capability for your fire control system, gun control system, moving the gun, aiming to the target, firing to the target. All these systems should be perfectly designed, perfectly aligned. Here this, I told GMS. This is sight. This is main gun. Now, wherever target is there, wherever gun is looking, there only sight should look. There only your sight should look. That's what I told camera. Wherever you are looking, your eye is looking, there only your camera should look. So if any mismatch is there, you don't get proper this one, no? So that's what the concept actually. Wherever this gun is looking, that the sight also should look. So that synchronization aspect, coincidence aspect, that we will be taking care using closed loop control system actually. If any deviation is there, we will be adjusting automatically by doing some small correction, manual correction. Okay, within fraction of second, within 2-3 seconds. Okay, now this is called line of sight and line of fire. What is line of fire? This main gun is there, no. Wherever gun is looking, no. That is line of fire. What is line of sight? Line of sight is wherever sensor, the sighting system, wherever it is looking, this point and this point should see at the same point. You understood? So that synchronization we will be achieving using multiple simulations, multiple iterations of the simulations by changing the different hardwares. Then once both will fall in the same window, sight, line of fire and line of sight. Then we will finalize. Now system is ready for firing like that. Okay. Now coming to brief discussion on this GMS, gunner's main sight, how it is developed, how it is designed. So it is having two small metallic mirrors which are mounted on the gimbal platform. There is a metallic platform, gimbal platform. On the gimbal platform, two mirrors are placed. So to know the position of the mirror, there is a sensor. So there is an encoder. Okay, there is an encoder. So encoder will give you the position of the mirror, whether it is at 1 degree, 2 degree, and actually we will take in terms of milliradians. And what 360 degrees is equal to 2 pi radians. What is 1 degree? 1 degree is equal to, you put 2 pi radians divided by 360. So it will come into 1 mil is equal to, 1 degree is equal to 17.77 milliradians. Well, how much 1 degree? This much only, 1 degree. Small, 1 degree. So in that 1 degree, 17.77 milliradians. Okay. Our firing accuracy, what we design the system is 0.4 milliradians. That means, 1 degree, you understood. 1 degree is equal to 70 milliradians. My firing accuracy is 0.4 milliradians. That means, we are blind man if I tell at 1 kilometer distance, if you put one dot with pencil and a board from here to that dot, I will hit accurate to the dot, day and night. So that is the firing accuracy we will get. Okay, so we are Arjun Tanya, we designed our system for a highest amount of FRHP will be first round heat probability. That's what I told. So greater than 95%. First round. Greater than 95%. If you miss the first round, what will happen? You understood that. So to avoid a second situation, we have to take care during the design of the system. Okay. Now, to achieve this FRHP 95%, what are all the things required? Accurate gun control system, accurate fire control system. Okay. So this main gun is there. That will anyway. Before that, I play 1 minute video. So we'll try to understand.
Arjun Mk.2 India. The Arjun Mk.2 is an improved version of the original Arjun main battle tank. It was developed in cooperation with Israeli defense companies. A total of 13 major improvements were made. After prolonged development, the original Arjun Mk.1 entered service with the Indian Army in 2004. However, the original MBT failed to impress the Army and improvements were required in order to make it combat-worthy. Also, Indian Army's fleet of aging Cold War-era T-55 and T-72M tanks became increasingly difficult to maintain and to keep in operational service. The new Arjun Mk.2 had improved protection, firepower, and mobility over its predecessor. Trials of the Arjun Mk.2 began in 2012. The tank was first publicly revealed in 2014. Production of 118 new tanks was approved by the Indian government and series production was expected to begin within the next few years. However, as with most Indian military programs, procurement of the Arjun Mk.2 was plagued with corruption and bureaucracy. The clearance for production was expired as it appeared that the Indian Army was evaluating prototype of the new tank for 2 years. Instead, the improved Arjun Mk.1A was ordered for production by the Indian Army. It has many features of the Arjun Mk.2, such as add-on armor kit, improved firepower, and remotely controlled weapon station. The Arjun Mk.2 has some design similarities with the German Leopard 285 main battle tank. It is claimed that this new Indian tank weighs a whopping 68 tons, which makes it the heaviest tank in the world. It is even heavier than the American M1A2 Abrams or British Challenger 2. The Arjun Mk.2 is criticized as being too heavy. There are many problems with its excessive weight, such as limited cross-country mobility, limiting air.
Okay. This video from Pakistan. Yes. Okay. So like that, we also will release some videos about their systems. Okay. Just I'm just like to say that share. Okay. So first you appreciate, then you depreciate. Okay. So these things are usual things. Okay. However you are efficient, however you are not efficient, but overall you have to project that. Okay, you are upper hand over the enemies. Okay, understood now? Yeah. So like this, there is some website, Park Defense. Sometimes you go and see. Okay, they'll be like discouraging the peak of Indian armed forces. Okay, like that we don't have anything efficient. Okay, fine. Now, where I am telling? Yeah. So GMS, gunner's main set, there will be two metallic mirrors which are mounted on gimbal. No, I will relate this for our solar panel design. That's why there is a link to this. That's why I'm explaining. Okay, there are two metallic mirrors mounted on gimbal. So the position of the mirror will be known from sensor encoder. Okay. So again encoder, there are like 2-3 variety of encoders are there. Okay, is it like optical encoder? Or what is the how encoder will give the output in bit pattern? Is it 19-bit pattern or 26-bit pattern? Okay, so how you are reading the position of the mirror in terms of bits, in terms of angle, in terms of number of bits. There is some electronics involved again. You have to convert that sensor output analog into digital. Again, you have to display this one. Again, you have to give some correction factor. Okay, now to stabilize that mirrors on the gimbal, there are gyros are used. What is gyros? What for gyro accelerometer? Okay, good. Anyway, nothing wrong, not doing. Okay, good. Now encoders, gyros. These are all the sensors for knowing the position of the objects and to see the speed. to velocity, to measure the, to know the velocity of the movement, angular movement, velocity of the angular movement. So gyro for knowing the angular displacement. Angular displacement. You know, if you have some mobile, no? So you switch on your gyro and just you move your mobile like this, no? Horizontally like this. So it will give you the angle, how much angle you rotated your mobile. There are features, even your mobile, all of us having the feature, accelerometer. Understood that? So sometimes you can see. Yeah. Now we were discussing encoders, gyros, and motors. How do you move this mirror, ma? How do you move this mirror? Using motors. So I want to use small compact motor, which is mounted to the mirror. In elevation direction, one motor. Azimuth direction, left and right. I want to see not only up and down. I want to see left side. I want to see right side also. So I want to move my mirror left and right. So I want to use one separate motor for azimuth axis movement, one separate motor for elevation movement. Now you understood that? So two motors, two encoders, two gyros, all are mounted on gimbal platform. Okay. So now this gimbal platform will take care of the oscillations, natural oscillations of the mirrors. Any self oscillations are there means those we have to correct it on the spot. You understood that? If I am not correcting, what will happen? You are looking at one point, but your mirror is looking at some other point. So you are firing bullet, it is not hitting the target, it is sitting 1 meter away from the target. 1 meter away from the target. So again, your aim is not met. You understood that? Now, similar phenomena we have to use while designing the solar space-based solar power stations. There we are using gigantic mirrors. Here we are using small mirrors. So there the big mirrors, so movement of these mirrors and the positioning mechanical fitment of that mirrors and reading the position angle of those mirrors all will be taken care by the necessary electronics control units. Okay. Now we will go back to presentation. Okay. Yeah, so I think we are here. We are here? Yeah, how it works. Yeah, now coming to the design part. Okay, so how to develop, how to design the space-based solar station. Okay, so yeah, I feel pity for all of you because some information may be repeated. It's the third day. But we have to discuss. There is no go. There is no other go. Okay? So you have to bear with me. Okay? In between, I'll go out of syllabus. Don't worry. I'll go out of syllabus in between. Okay. So space-based solar power essentially consists of three major elements. So the first element is that it is a means of collecting solar power in space. For example, via solar concentrators, solar cells. That's what PV cell I told. Or heat engine. Second element is the means of transmitting this power to Earth, for example via microwave or laser means. The third important element is the means of receiving power on the Earth, for example via microwave antenna. There is a rectenna, that is also called rectenna. So there is some source required on the Earth there to receive the power which is transmitted from the space. Okay. You would have seen yesterday all this. Yeah. Just if you see the basic things, how this will be processed, how you are generating the space-based solar power. So you see the top portion, the white color top portion, like a hat. So that is like what we say. The sun sends out photons and energetic packets of light in every direction. So sun is have a limitation. Only this angle I have to transmit sun rays. No, in all directions you will be receiving. That means all those sun rays will be collected using this I can say mirrors or I can say like mirrors, solar mirrors like solar reflectors. I can say mirrors or solar reflectors. As I concentrate the sun's photons onto the sandwich like modules. So sandwich module I can say the center of the you can see that dome kind of thing here actually. The center of the reflector is like dome kind of thing. That means you are collecting all the sun rays and you are converting that, and then from one point you are transmitting that actually like a space-based solar power. Yeah, I can say number 2 like solar reflector, and number 3 here you see is like it's not visible text wise. Is a solar reflector. Now sandwich model, like it is like array. It's like the number is like sandwich model is an array actually. So what this will do, like this array, solar panels array, this will receive that energy from these reflectors. Like more detail I want to say, you assume 2 mirrors are there. From these 2 mirrors, solar rays are reflected. They are falling onto this one, and that is coming to this receiving panel, solar panel I can say. From this solar panel, like not one, like many combination of many this one. So from that again energy will be converted in the means of like to receive to the earth. Like 2 means are there for microwave, by means of microwave method or laser method. So both methods are having pros and cons. Okay, so safety aspect, losses, amount of losses, directionality, lot of parameters are there to take whether which mode of transmission, power transmission, minus power turbine, minus power transmission. Okay, the basic thing actually. I can see here this is the satellite. So from there microwave power power beam. And the electric subsystem of rectangle on earth is on earth rectangle. I can say rectifying antenna. So so coming and then it is absorbing from here it is using for the purpose like household purpose, different roads purpose, all this actually. Okay. So here the structure of this rectangle antenna, how big it should be, what are the elements inside this rectangle, all these things we will discuss one by one. So, but basic principle is this only. So, there will be solar reflectors. From solar reflectors, the solar rays will be collected, and the solar rays energy will be collected. That will be that energy conversion will be taking place here. So, in the form of electromagnetic energy. So, that electromagnetic energy again will be converted in the form of laser or microwave, such a way that it has to travel to Earth by means of laser or microwave. Okay, so that will be received by the rectangle on the Earth actually. From the rectangle will be transferring to loads, different loads. So again same thing. So different version of design. So from the sun, you are receiving the sun rays. Okay, the parabolic this one. So this is your concentrator like which focuses sunlight on this one space-based cell. So it is a PV cell array, the bottom PV cell array. So after reflecting this one solar this one cell, here also the solar is falling here, reflecting to PV array, photovoltaic array. Again here solar is collecting here, reflecting here. So collecting here, reflecting here. So these are the different design approach. These are different design architecture. So all the sun rays will fault on this PV array, like this powers the laser diode. So the PV array is designed with the laser diode. So this laser diode pumps the fibers. So all this energy will be in the form of light from fibers is spread to optics and transmitted to earth. This is by means of your laser medium of transmitter. So laser will be using as a medium here. So that will be again that you have DC electricity converted to AC. Again that AC will be transmitted, and the electric station that AC will be again converted back to DC such a way that the loads will utilize the DC for charging all the batteries. From the charged batteries, your loads will be powered up again. So power is distributed to different consumers, whether it is industry or whether it is charging station, whether it is homes, whatever it is. Okay. Different approach. Yeah. So again, we already discussed how it works. Right? There is a solar panel, on the medium of this one. Okay. So signal sent from receiving antenna on at the green, this one. So allows satellite to pinpoint this microwave beam. That's what I told. Orientation of beam, orientation of mirrors or satellite. Orientation of satellite, the design of your system such a way that it should be accurately oriented. Such a way that you have to orient your laser beam or your microwave beam exactly towards your antenna. So whenever your receiving antenna is there on the antenna, so there only you have to focus. You have to point. Beam pointing will call. You have to point that. You have to point your laser beam or microwave this one exactly to match with the line of sight. LOS of your retina, which is positioned on the earth. Okay. This is again one more different approach. So there are like whatever first initially I told you, two metallic mirrors. Different approaches. The approach 1, approach 2, approach 3, like that. So there are two metallic mirrors. So from these two giant mirrors, I don't know. From the giant mirrors, solar rays are collected and then reflected back onto the assembly. From there, highest amount of energy will be concentrated. Again, conversion from solar, energy from solar rays into microwave to suit microwave method or laser this one. Again, converting, transmitting that energy to at the station, I can say, rectangle, I can say again. So there is a different approach actually. Okay. Here, earthbound receivers, rectangle, whatever I told, that covers farmland, like farmland or your free space wherever is available. You can design, you can place your retinas. If you have any bigger, larger buildings, that buildings also you can use this retinas. But very rarely those buildings, 1 kilometer building you may not be having. Maybe multiple buildings which are giving the space of 1 kilometer. Maybe 10 floors buildings of 5, 6 are there in a place of 10 kilometers. So that maybe there's like future scope. You can place retinas there also. So that your losses will be reduced. You see, retina is there somewhere 50 kilometers away, or retina is there just above your building, which is preferable. Yeah, above the building preferable. So that option also, any provisions are there. That provisions will be we should work out those also. Yeah, after that, so the from the rectangle, power will be going to your this one, whatever grid, electrical grid, okay, from electrical grid. Again, you have to interlink all this. You have to communicate communication between the rectangle and your station, space station. Communication between your power grid and the rectangle. Communication between the 8 mirrors assemblies. All these things will be taken care during design. Okay, so there is no space for flaw. Yeah, coming to cost aspect, cost aspect if you study. So there like recently, if you see somewhere in 2015, not recently, maybe before some maybe 8 or 9 years. So these like some graph released from the USA. Payload capability of launcher, payload capability of launcher. Yeah, before discussing launcher here, what we will do? We will design the full hardware, gigantic mirrors, reflectors, all the energy conversion hardware which are required. We will design on the laboratories. From labs, we will be transporting using the launchers actually. Using the launcher, you have to, like your satellites, so how you are transporting your satellite from Earth to orbit. The similar manner, this space-based solar power. So this also will be transported using your launch vehicles. So what is the cost involved in the transportation? Like in terms of your, how much weight and how much price per kg. No, so like a specific cost input in terms of dollars. Like for example, 20,000 kg payload, for example, 20,000 kg. Okay, if your total weight of your hardware is 20,000 kg means, so what is your expenditure? Around $10,000. 10,000, not dollars, billion somewhere. You can see the cost equal to dollars per kg, dollars per kg. 20,000 means the correspondingly this one cost aspects, pricing aspects. Okay, that means what is the point here? Huge cost is involved in developing the hardware, one-time cost. Okay, so we should be ready. We should be like funding wise, we should be ready for if your hardware is more, your payload is more means your cost also high. That's the point here. Your payload is more means your cost is high. Your cost is high means your system also having very big giant mirrors. Your energy, your revenue also in the same manner. So your energy output, that is also high actually. Yeah. So the basic idea is at no place on the earth does the sun shine as bright as in case of its geosynchronous orbit. Yeah, that's true. So whatever you are getting the intensity, light intensity on the geostationary orbit, obviously it is very, very high than the same intensity on the same place received at the earth actually. So that located in space. So what is the area of this one? 22,236 miles. Up like where this satellite can keep a spot on Earth in steady all day, every day. That means there is a huge area of your space available. There is a point here. 22,000 to approximately 22,236 miles. If you place one satellite means again, so power station. If you place one power station, that can accurately aid your rectangle which is placed on the Earth. So high above the gauzy atmosphere, they can intercept like the 35 to 70%. That is the losses. Here what is the losses? We have to calculate for the losses. That means 100 watts you are expecting output means you have to design your system for 170 watts. So here loss is 70 watts. So while designing your system, you have to cater for the all types of losses also. So say for example X amount of loss may occur. So that X amount of loss you have to add in your output. So 100 watts you want means you have to design 170 or 200 watts your system design should cater. So that you will get only 100 watts. You understood the point, right? Like your system, like your design is over design. You should always go for over design, not under design. So if you want 100 watts power, if you are designing for 80 watts, how much you will get? Only 10 watts you will get after losses. You got the point, no? So that means always, space-based station should always go for the over design. Not only over design. If you go for over design, what is the problem? Cost. If you go for over design, you have to invest more amount. Okay. So now you look at it. So I want only 100 watts power output, but my system design 200 watts. I have to design my system. Understood that? So now what is the amount required for 100 watts? What is the amount required for design? Is equal to 200 watts and 2 times. Understood that? So that's one of the points actually, one of the challenge actually. That means why this 2 times cost? Why? Cost wise. Why 2 times cost? For example. So for example, because all your hardware is costly. That means if you take gigantic mirror, the area, the material, design, accuracy, sensitivity, all those aspects you have to ensure. So here, while designing optical mirror, what are the parameters you have to see? Reflectivity. Okay. So what is the percentage of reflectivity? So for example, any mirror will be having 100% reflectivity. Obviously no. We are not that much accurate. Definitely there will be some losses. Say for example 20% losses there. That means reflectivity is 80%. Understood that? So whatever your mirrors in home, for example, they are also having one factor called reflectivity. Understood that? So again, the ability to receive effectively, the incident, like laser, solar laser incident in the falling in the mirrors, so that while interface with the metal, there also there's a factor. There also there are some losses may occur actually. Losses during incidents. Understood? All these points we have to keep it in mind while design. That's why cost is. That's why cost overrun. We will tell cost overrun. Cost will go up and up for your over design. Understood? Yeah. Why this cost is going higher? I mean, since the systems are above Gaussian atmosphere and the systems can intercept the solar rays 70% more intense than mid-noon sunlight on the ground actually. So, but if you assume same system which you are developing for a space-based, same design you want to do for all the Earth means, what is your cost? It will be less or more? It will be less. Because on Earth, you did not have 1 kilometer diameter mirror, correct? And you don't have that space also. You will be having only free space, 10 acres, 20 acres. So there only you have to design. But the cost aspect, obviously, it will be lesser than the space. Yeah. Now the challenge is again cost. Challenge is cost. That means investment. One of the important aspect actually, commercial space power station. So a commercial SPS, commercial power station, that is capable of producing 1 gigawatt. 1 gigawatt. So what is 1 gigawatt? Okay, so 1 watt, 10 watt, 100 watt, okay, 1000 watts, okay. So 1000 watts, 1 kilowatt. Okay, so like that. 100, 200 kilowatt, 300 kilowatt, 1000 kilowatt. Okay, so 1 gigawatt, like that. So to design, like to have a system which can produce 1 gigawatt. Okay, so that will be a magnificent structure that will, the weight of that also is more than 10,000 metric ton. Yeah, here, what is ton again? What is ton? 1,000? That means 10,000 metric tons. Now here one factor. So to transport, Earth to space, 10,000 metric tons weight. 10,000 metric tons means you assume how will be my launcher design. You need launcher with. You need a launcher to take your hardware from Earth station to space. Yeah, 10,000 metric tons means what is the design of your launch vehicle? Huge. It will be very huge. And what is the cost?
High cost.
Very high. Now you understand what is the challenge, na? So first slide we conclude one statement. So last slide we will conclude with different statement. Okay? Yeah. Now like it measures several kilometers across. 10,000 metric tons weight. You can see the length of the launching vehicle. Length of launcher vehicle. Definitely it will be a very high length, very huge length. So to complete and operate an electricity system based on such big satellites, we would have to demonstrate mastery of 6 different disciplines. What I told. So this area is multidisciplinary vision. This one, lot of things are involved. People from optics, people from electronics and computers background, people from mechanical experts, okay, people from microwave experts, okay. So multidisciplinary activities are involved in designing the space-based solar system. Say for example, WPT, wireless power transmission. So have you ever seen WPT in home? I want answers from you. Bluetooth, Wi-Fi, okay, many are there. Okay, like that, WPT from space to earth, So there, how much design care you have to take? You assume. See, one time your Bluetooth is not working, means you are struggling. One time your Wi-Fi is not working, means you are struggling. So I can switch on my fan wirelessly. So if any problem I have to struggle, where is the fault, which hardware, which sensor has got faulty, where the power 5 volts DC is not going to my transistor or whatever switching element is there, FET, MOSFET, whatever is there. So to transmit gigawatts of power from space to earth, how much care you have to take. This is one of the challenge, design challenge I can say. Wireless power transmission, one of the area huge, the massive research is required and research is going on. WPT, wireless power transfer in terms of gigawatts. Okay. Yeah. Next, space transportation. So we are discussing this space transportation. Okay. Tomorrow you want to shift your station from one location to another location. How do you do? You want to change your location. For example, okay, you already placed one satellite in orbit. It after 10 years. Say for example, the life cycle time of that satellite is 10 years. Okay. Now, how do you calculate life cycle? There are different jargons we are using. Life cycle. How do you calculate? Based on? Yeah, I do. I'll use one small PCB. In that, what is the lifetime of you, me?
100 years.
You can approximate. 60 years? 70 years? Okay, you are good positive, 70 years. Okay, good. Take 70 years. So how do you measure? By seeing your lifestyle, using medical and advancements in medical field, then the food you are using, and the oxygen you are getting, how pure it is. You know what happened in Delhi? People use oxygen masks. So you know about situation, you have to carry oxygen bag along with your college bag. Okay, so based on all these aspects, you will calculate a life cycle. Similarly, for any hardware you are developing, any PCBs you are developing, you can calculate the life cycle. What is MTBFL? Mean time between failure. Okay, your heart is running continuously, 24/7. What is MTBF for the heart? 3 times. That means maximum you will say 3 times you will get heart attack. 4th time no guarantee. You understood that? So like that, if you are using any MOSFET, or IGBT, your PCB, the manufacturer of the IGBT will be specifying that this IGBT, this MOSFET can operate 10,000 times. Okay, if you operate more than 10,000 times, what will happen? It may fail. Okay, so now the life cycle of the PCB, you can say maximum 10,000 cycles. Or in one day you are operating 1,000 times, for example. So you can say 1,000 days. 1,000 days is the life cycle of this particular PCB where my IGBT or the FET is there. You understand the concept? How to calculate life cycle? Like that, for a space-based solar station, what is the life cycle? Based on your hardware, based on your software versions development. Software you can't say life cycle development, you can say half an hour life cycle software. Agreed? Take 10 minutes, different version of software will come. You will update different code. You will give different version. Version control will come. Understood that? So life cycle for the hardware based on the what are the components we are using in the design, which components is having how much life cycle, number of operations. So based on overall, you have to consider all the things. and you have to calculate MTBF, mean time between the failure. Say for example, one component is failing frequently. What you will do? You have to replace that every time. Okay. Now, what is the life cycle of that particular component? Less, maybe 1 year. Instead of 10,000 cycles, you can conclude 100 cycles, 100 times. My MOSFET is failing every time. Okay, this was generally I felt in the lab. Every time I put the MOSFET is failing, gate current is flowing more than limit, the ICP is failing, and full room is smell of this one. Everybody knows, okay, Ramana one MOSFET gone, so again one more MOSFET. Okay, one more amount wasted. But what to do? It's a research, you have to, there is no other way. I can't put my finger in place of MOSFET. Then I will no more. Just I'm telling next. Okay? Yeah. So what is this discussion here? Yeah, life cycle calculation. Yeah. So life cycle calculation based on the different hardware you are using by the design. So based on that you will be calculating. There are softwares for calculating life cycle. There are very good software tools are there. So just to enter what are the BOM? What is BOM? Bill of material. If you design any one PCB, what are all the components you are putting in the PCB, you will be preparing one Excel sheet. In the Excel sheet, MOSFET 10 numbers, IGBT 10 numbers, normal switch, push-pull, a switch 10 numbers. So this is called BOM, Bill of Materials. In the Bill of Materials Excel sheet, you will be mentioning all the hardware. So that you will be exporting this Excel sheet to the software tool. So the software tool will calculate standard this one. See, MOSFET means normally you will go for which company? Standard companies will be there. So standard companies they use your original processor, for example, microprocessor or a Texas Instruments processor or a PMS, this one DSP process. So each Texas Instruments processor will be having its own life cycle, like 1 lakh times of operation or 10,000 times of operation. So by taking all these parameters into consideration, so there are software tools available. It will give you the life cycle of the overall system. You understood the basic concept? Yeah. Where are we? Yeah. Okay. Locating the. I mean, if you, tomorrow you want to, I want to remove the system station. I want to relocate it to some other place. What are the things required? Transportation. That's called space transportation. So there again you have to develop means how to transport. You need some vehicles. Transporting vehicles from space from position A to position B. So some 10 miles away or some 20 miles away from the source station. Like that. So that also cost involves actually. This is also one of the major challenge I can say. Yeah, wireless power transmission, space transportation, construction of large structures in orbit. So, on Earth, maximum you can consider 1 meter by 1 meter PV cell on your home rooftop. Or industry means maybe 10 meters by 10 meters, or maybe higher than this. Okay, but in space, not like small. It's very big, 1 kilometer, 10 kilometer, 50 kilometers. Okay, the area of the PV cells which are connected in the series parallel combination. So that means constructing huge structures and positioning those huge structures in the orbit to the desired angle of incidence with respect to sun. So these are all areas actually. So we are discussing constraints. There are 6 major constraints while designing the space-based stations. That's what we are discussing. Okay. That means construction of large structures in orbit. That's also one of the area we have to research to be done actually. Then satellite attitude and orbit control. Yeah, here what is attitude control? What is attitude control? What is attitude basically? Not human attitude. Okay. So yeah. So there are some systems which are designed, I can say for example battery tank. Say battery tank. It's also video. Say for example battery tank. So battery tank is having attitude control. Attitude control in the sense, for example, what is your height? 5 feet, for example. If you want to reduce your height by half meter, 4.5 meters. Just like a second. So if you want to increase by another 5 meters, like our meter. Understood that? So you have to, that's called attitude. And attitude is not human, it's system. Okay? So we can design systems parameters attitude control. That means based on the solar rays, how solar rays are incidenting. Based on that, your attitude should be controlled. Attitude, I can say in bright language, height control. You have the spring. You can control no attitude. Okay, so that's one. Yeah. Elaborate we will see further slides. This attitude control. There are algorithms are there. There are very good algorithms are there. Very proven algorithms are there for this attitude control and orbit control. Power generation and power management. Coming to power management. What is power management? Power generation we have seen. What we discussed. What is power management? Managing the power. Okay, very good. Power management. How can you manage power? Say for example, in my computer lab, I have 10 computers. Okay? So I have to design a system, intelligent power management system. Okay? So I have a mechanism. Whenever two people are sitting at two nodes, only the two nodes should be powered. Wirelessly. Whenever 10 people are there, all 10 systems should be powered. Whenever person is not sitting in front of computer, that should be off. Power should get cut off. Okay? So this is called intelligent power management system. Again, you have to write an algorithm depending upon the sensor output. Okay? So put one camera, whenever person is sitting, that camera will give the output, and the algorithm will take care, power should communicate to the PC. You understood? Huh? Now, engine is there, your car, engine is there. From engine, power is coming. It will be steered, it will be connected to the wheels, engine wheels. Okay? There also, intelligent power management is there. Okay, when engine is idle condition, when engine is peak exertion condition, when engine is nominal condition. So different based on the different moment of your steering, power transmission will be controlled. Okay, effectively. So that is called power management. So similar power management for the space-based solar system also. Okay, so it's one of the area where you have to work out techniques to intelligently manage your power. This is for internal hardware and telling. So power for energizing your systems, energizing your whatever electronics is there, whatever optic systems are there, whatever sensors are there, to energize the system, subsystems of the system. So that is power management, intelligent power management. Okay, so out of all these discussing the challenges, it's the wireless power transmission that remains the most daunting area, most complex area. Where very gray area. So wireless power transmission, WPT from space to Earth. So that's one of the daunting area where a lot of research is demanded. Okay. So with this, I will conclude before lunch. We'll be ready for lunch. Okay. Thank you.
I just want to add one more point. Yes, next. Yeah, okay. So here I want to add one more point for clarification. My clarification is in English. This is dear students, here this entire setup, just observe P is PV is there. What is PV? And here one more device is there. This one is so what is the purpose of photo Excel? Yes, sorry, it converts solar energy to electricity. So in our college room also we have solar panels, right? So we have a wiring facility. That electricity is directly supplied to the purpose of utilization. And here we don't have, we have a large distance between photovoltaic cell to earth level. Okay? So that's why there is a question. That photovoltaic cell, next setup to the photovoltaic cell is laser diode. And what is the purpose of laser diode? Do you know? Converts electricity to light. Okay. So again, the electricity which is produced at the satellite panel is again converted back to light, and that light is reached to earth and there is some setup. So that means this entire setup has several set of devices for working. For effectively working, there is a several set of devices. That I want to add one more point this discussion. Thank you.
Sir rightly pointed out. So this PV cell, this circuit PV cell and this laser diode, and design of PV cell array. This may be after lunch post session, post lunch session, we may discuss in more detail. Okay. Thank you.